from the sine version. It's a little, I think it's a little easier because your answers come out nicer. So we have the cosine squared of x is equal to 160. What's our first step here to find our, what x is, what the angle is? Take square root, so that'll give me the cosine of x is equal to what? Plus or minus 1/4. So that's two equations. The cosine of x equals positive 1/4, and the cosine of x equals negative 1/4. So let's go with this one. What do I need to do to solve this equation? How do I leave the x over here and I can't subtract? This is the name of a function.
Inverse cosine.
Inverse cosine. I gotta undo the function. So I do the inverse cosine. I'll have x equals, and it will give me the arc cosine of 1/4. Where is the arc cosine of 1/4? And how did it get there? Is it in quadrant 1, 2, 3, or 4? 1. Okay, good. How did it get there? Did it get there by going in the positive direction and no more than one time around? Yeah, so this angle right here is actually between 0 and 2 pi. And if you want to know exactly what it is, well, okay, I shouldn't say that. If you want a numerical representation of it, you can stick it into your calculator. Make sure you're in radians though, because you're looking for something in radians here. Now, there is some place else, one time around the circle, where the cosine of the angle is going to be a positive 1/4. Where is that going to happen? Where else will that happen? It happened in quadrant 1. Quadrant 4. So basically I need to figure out how to get to quadrant 4. Well, basically what I do is I get the reference angle. Well, what is the reference angle here? Right, this is in quadrant 1, so the reference angle is just the angle itself, so that's going to be the arc cosine of 1/4. And then I want to put that into quadrant 4. So how do I do reference angles in quadrant 4?
2 pi minus
Right, how many, did you say 2 pi?
Yeah.
Yeah, so reference angle, oh, I should finish quadrant 4, is going to equal 2 pi minus the angle. This is the angle we're going to be looking for. Well, we know the reference angle is the arc cosine of 1/4. So we have arc cosine of 1/4 equals 2 pi minus the angle. And I want to solve this for the angle. Suggestions? Move 2 pi over. I can do that by subtracting. So I'll have minus 2 pi plus the arc cosine of 1/4 is equal to negative of the angle. And then what? Multiply both sides by a negative. When I multiply this by negative, it'll become a positive 2 pi. When I multiply this by a negative, it's going to be minus arc cosine of 1/4 is going to be the angle. So those are the two angles, this one and this one, that will produce a positive cosine value of 1/4. Cosine value is positive 1/4. Okay? That one's the easy one. This one's a little harder. A little more work. Well, now let's do the same process here and see what happens. How do I solve for x here?
Same way.
Same way. So I'll have x equals arc cosine of negative 1/4. Where is this and how did it get there? It's in quadrant 2. Did it get there by going from 0 to 2 pi and not passing 2 pi? Yes? No? Maybe? Maybe. Okay, wait. Where does your inverse cosine come out? No, but where does your inverse cosine come out? the range for the inverse cosine function has to be between what and what? So that means it goes from 0 to pi, right? So that means this is either gonna have to be in quadrant 1 or quadrant 2, because 0 to pi takes over quadrant 1 and quadrant 2. Which one will produce cosine values that are negative? That'll be quadrant 2. So that's why we know this angle is in quadrant 2. Whatever its numerical value is gonna be a quadrant 2 value. No. We just need to know that it's in quadrant 2.
What about the sine?
Sine was a problem because remember sine comes out between negative pi over 2 and pi over 2. So the positive ones work exactly like this. The negative ones, you have to first add 2 pi to get it in the right direction because it's, the ones in quadrant 4 get there by going negatively, not in the positive direction. That's why I asked how did it get there too.
Right, okay, so it's gonna be 4 and 1 or something.
Right, 4 and 1 for inverse sine. All right, so we know we're in quadrant 2. We need a reference angle because then we're going to take a reference angle and put it into quadrant. What other quadrant's going to produce a negative cosine value? 3. So we'll take our reference angle and put it into quadrant 3. So in quadrant 2, how do we find our reference angle? Yeah. It's going to be pi minus the angle. Well, here's our angle. It's the arc cosine of negative 1/4. Now we want to take that reference angle. I know it's a big messy one, but we want to take that and put it into quadrant 3. So what's our rule for quadrant 3 reference angles? Anybody remember? It's going to be the angle minus pi. So our reference angle we know is pi minus the arc cosine of negative 1/4. That's equal to the other angle we're looking for. Since I already used the word angle over here, I'm going to do angle 2. Second angle minus pi. How do I solve that one for the angle that we're looking for, angle 2? Add pi. So when I add pi to this side, I end up with 2 pi's. Yeah. So I'll have 2 pi minus the arc cosine of negative 1/4, and that's going to be the second angle that we're looking for. So this is the second one that produces the negative cosine value, and this was the first one that produced the negative cosine value. And when it comes to putting them into